We're going to use the exact same process, all the steps in the same order. The only difference we have now is that A is not 1, which means that thing that we skipped the first time, we're not going to get to skip this time. So, start where we started last time. Move the constant to the right side. So let's move that 4 over here. So now it says 2x squared minus 6x equals negative 4. Starts the exact same way. Move the constant to the right. We do not want it to equal 0 anymore. It actually does not matter if you do that first or this first. It will not make any difference. I'm just going top to bottom. Now, we have to actually pay attention to this part. If A is not 1, and it's not, you must, underline this, divide everything by A. Which number is A?
2.
2. Divide everything by 2. This divided by 2, this divided by 2, that divided by 2. Well, 2 divided by 2 is 1, so now it's 1x squared. 6 divided by 2 is 3, so now it's minus 3x. And 4 divided by 2 is 2, so now it equals negative 2. That is the only extra step that is in this example. Everything else we are going to do is exactly the same process as the last one. If A is not 1, you will not be able to get a perfect square trinomial in step 3, which is what we're trying to do in step 2. You absolutely have to have it, otherwise the rest of this process is impossible. Okay? Okay, so let's do this next part. B, divide B by 2, then square it. So let's write that formula like we did last time, and I do want you to write this. B divided by 2, and then square it. Which number is B now? 3. Negative 3. Uh-oh. Negative 3 divided by 2, and then square it. Well, this is unfortunate, because now we have a fraction. So, our final answer will still work out fine. To make this into a fraction itself, when we square this, square the top and bottom separately. What is negative 3 times negative 3? And what is 2 times 2? Great. Here's the problem. Even though the process is the same, we don't know how to factor when there's a fraction in the problem. So I'm going to show you a shortcut. First of all, let's do this. Add that term to both sides. So we had our equation up here, x squared minus 3x, but now we have to add 9/4 equals, and we had a negative 2, and again we're going to add 9/4. Now this is going to cause a little bit of a headache for some people. But we are going to move forward with this. Here's our first issue. Having a fraction there means, how the heck am I supposed to do x method? We can't do x method if there's fractions in it. So here's what I'm going to tell you. Every single time that you are supposed to factor to make a perfect square trinomial, the same shortcut will always apply. And I'm going to show you what it was in the last example, and then we'll apply it here. If you turn back to our last example, look at the squared trinomial that we ended up with. It said x plus 2. Look at the work we did in step 2. When we cut this in half, we ended up with a 2. This number here, before you square it, that number is always what's going to go here. So let's take a look, because that's going to simplify this process for us a lot. Before I squared it, what number did I have in parentheses? Negative 3 over 2. So here's all I have to do. X minus 3 over 2. If we could do X method with a fraction, that's what we would find anyway. It will always work that way. Guaranteed. So, that number in parentheses, right there, the negative 3 over 2, before I squared it, that number right there is what's going to go in parentheses when I'm done factoring. Always, every single time. Here's the other problem, though. We have to simplify the right side. So, I'm supposed to take negative 2 and add 9/4. For adding with fractions, we need a common denominator. Negative 2 is actually negative 8 over 4. And if I add 9/4, I have x minus 3 halves squared equals, what's negative 8 plus 9? Positive 1/4. The rest of this problem will be very easy. Just to recap what we did there, because this is the part that I see people make the most mistakes on, I took a whole negative 2, and I said, I'm adding a fraction. If I'm adding a fraction, I need a common denominator. So I asked myself, what number over 4 is equal to 2? And that would be 8. 8 over 4 is equal to 2. Add them up, there's our new number. The rest of this is much easier. Let's rewrite that equation we just created. And here's the great part about this. In setting up completing the square, when it says take the square root of each side, all the numbers that I'm using have square roots. Square root cancels squared. So x minus 3 halves equals, what's the square root of 1? 1. What's the square root of 4? 2. What am I missing? That's the one. Plus or minus. Remember, square roots give us 2 options. Now, I know this still doesn't look simplified, but it is. And let me show you in the last step how this actually is an easy process. We're going to solve both for positive 1/2 and negative 1/2. X minus 3 halves equals positive 1/2, and x minus 3 halves equals negative 1/2. I know this doesn't sound easy yet, but look, they already have a common denominator. I'm not going to have to do anything crazy with this. When I add 3 halves, what is 1/2 plus 3 halves? 4 halves. What's 4 halves? There you go. There's our first answer. Again, this whole process sets us up to have common denominators. On this one, if I add 3 halves to both sides, what's negative 1/2 plus 3 halves? 2 halves. What's 2 halves? 1.